Hi, this is Nick. I spent the last week doing some demolition. We found a lot of code violations. I've got a lot of things to show you, so I'm going to try and move through them as fast as possible. The first thing you see here is a temporary transformer set up by the DWP outside of a facility that we worked on. The transformer on the pole exploded because it was overloaded. We asked the DWP for 400 or 600 amps at 480 volts of power for this building, and they gave us 150 or 200 amps, so their transformer basically exploded. So here's the temporary that they put up. The thing about the DWP is that they didn't violate any specific NFPA reference in undersizing their transformer. Electric utilities are not covered by the National Electric Code. They have their own standard. The interesting thing about that is that they don't get inspections very often, so they tend not to even apply their own standards. You will find a lot of fairly shoddy DWP work. But looking in the code, you'll see that in Article 90.1b says specifically that any installations under the exclusive control of an electric utility are not going to be covered by the scope of this book. We can't enforce them to follow our rules, but they do have their own. This next job, we are gutting the interior of a facility and we're bringing it back to an empty warehouse. The electricians that did this work did a lot of things which could have caused a fire or people to get hurt. So this is a sub panel and some gear that they have. You can see here they used a gutter to put in about 20 contactors. They didn't leave very much space for the wiring. This gutter is just too small. The calculations for gutters like this, or any box, can be found in the code under 314.16. It is actually an equation that you have to do based off of all the wires that are there and the overall cubic inches of space in the box. Visually, you can see this box is very much so overly filled. It is impossible to work in that. It was almost impossible just to demolish that. Here's another example of an overly full box, but since this is actually a panel board, it is covered under 312.7. 312.7 says space in enclosures, cabinets, and cutout boxes shall have sufficient space to accommodate all conductors installed in them without crowding. So without crowding is a little bit open to interpretation, but I think it applies here. Just as a note, they used all the same color wire, which makes things fairly difficult to work with, especially since most of these loads are 240 loads. So on this panel, if you go 3 and 4 breakers down, you'll see that on both sides they're running 240 volt loads using white wire. The space in this board is much better, but they shouldn't be running hot loads with white wire. In the code book, all of chapter 2, which is 200 and on, is talking about wiring. In 200.7a, it says a conductor with continuous white or gray covering can only be used for a grounded circuit conductor or a neutral. You cannot put live voltage on these wires. Here you have the ground wire coming in through the conduit, being twisted around itself, and then run into the back of the devices. There's no connection to the box. In the section on grounding and bonding, which is Article 250, you have 250.110, which is equipment fastened in place. So this box being screwed to a wall would be considered fastened in place. On point 5, it does say that where supplied by a wiring method that provides an equipment grounding conductor, that box has to be connected to that equipment grounding conductor. Even if it's also electrically connected back to ground by the conduit, it also has to connect to the ground wire by that point. As a side note here, that box wasn't actually connected all the way back to the panel with conduit. It was connected to a 3/8 flex, and that flex had come out of the back of the box. There was really no electrical connectivity that would be suitable for a ground at all for that box. Here you have the grounding wire going to a screw on the box. I do believe there is a code point that says don't put it on the screws for the lid, but this other code point also applies. This is also in the section on grounding and bonding, Article 250, but this is Article 250.8, and this shows all of the acceptable methods of putting a ground wire to a box. One of them would be using a machine screw with more than 2 threads connected to the metal, but not just using this thing on the corner of the box. That's not an acceptable method of grounding it. This is a wiring method that doesn't work very well, and it's also considered illegal. This is the use of 3/8 flex. The smallest flex you're allowed to use is 1/2 inch. They do sell 3/8, but that's for machinery. It's not really supposed to be used for wiring general installations. All of the flex rules are covered in code 348, but 348.20a specifically says how small you can use flex, and it says that 1/2 inch is the smallest you can use. Here they've gone ahead and plugged in a couple of number 10s and attached them to a 30 amp breaker, and then plugged them into a couple of typical 110 volt outlets, and they plug them into normal wall receptacles that you could plug your vacuum cleaner into. This is very dangerous. You could plug a piece of equipment into this and have it explode on you. The plug for that equipment is supposed to limit it to being used for 110 volts, and here you're plugging it into 220 up to 240. Article 400 is completely concerned with general equipment. In 406.4, there's a section F which addresses this specifically. F says that when you have 110 volt circuits and you also have 220 volt receptacles, you have to use plugs which won't allow equipment to be interchanged between 110 and 220. You actually buy a plug that has a different prong set for it, so it won't accept a normal 110 volt plug. The other code point here is that they're using a receptacle which is rated for 110 volts, and they're plugging in 220 volts to it. This is exceeding its rating. That's code point 110.4, which goes over voltages, and you can't exceed the rating of the device that you're energizing with too much voltage. Okay, so this is very dangerous. This particular floor, if you notice, the walls behind there are plastic. That's because what they were manufacturing here involved a lot of water. These plugs that my foreman is holding there actually have their prongs energized. So when the breaker is on and that time clock is on behind him, those prongs just energize. So a person could be holding this plug and they have live metal parts that are exposed to be touched, and they could be standing on a very wet floor. This is a serious life hazard issue, especially since the switching mechanism for these prongs is automatic. It's based off of a time clock. The code point that covers this is talking about plugs. It's under the equipment section of the code, which is the whole 400 section is equipment. The specific number is 406.7b, and that says that attachment plugs shall be installed so that their prongs, blades, or pins are not energized. Okay, so here you'll see there's several cables coming out of a box over a panel. They're going about 6 feet, and they have female ends on them. So they don't have energized prongs. However, this is an improper use of cables. The only uses permitted for cables are gone over in 400.7. They're mostly used for flexible connections to equipment or equipment that needs to be changed out. This installation seems to be so that they could plug a bunch of extension cords into cables easily. This is a really lazy way to do electrical, and it's actually against that code. Alright, I'm Nick. I'd just like to thank you guys for watching. I'd like to thank my foreman and my boss for letting me take a bunch of pictures on the job. What I'm trying to do with this video log is to give people a head start in becoming an electrician. So if there are any questions that you have that I could address, I would appreciate any feedback that you give me. I hope this does help, and I'll do some more videos in the future.